whole lot.
Yeah, we told you.
Right.
Bring it over.
I would possibly you should hold that. How tired can you be? Very.
Oh, be.
How do you feel in your 80s if you have not gonna make it.
You're gonna say, I wish I would have appreciated when I was 18 how young I felt. No. Okay, so here's the deal. Whether you know it or not, you have a huge, huge gaping hole in your toolkit. It's like a mechanical that has no. I can't remember what I was going to say. Anyway, you're missing something. Forgot the analogy. Whatever. You're missing this big skill. Okay. Now, U-sub is an awesome skill, and it's the most useful integration skill other than just basics. Trig sub is a little after. Unfortunately, trig sub they teach it in Calc 2 for a reason. It's harder to do than U-sub. Okay. It's super useful, but it'll take some thought. All right. Now, the idea is that you have tons of integrals that you cannot integrate. 1 minus x squared, if that were a definite integral, we'd probably do that how? It's a circle and you do it geometrically, right? But if you were to actually integrate that indefinite integral, you'd go nowhere because we have not done that. There's no way to do it. There's no U substitution that will ever get you there. You just go nowhere. With trig sub, though, it's really pretty straightforward. All these are non-U sub candidates because no matter what substitution you make, it can't be done by U sub, right? So with trig sub, you can do these. Now the idea is this: rather than substitute a U in for x or whatever the expression is, you substitute a trig expression, like let x equal sine of theta. Now why would you do that? Is because then it allows you to use identities. What if this were sine theta? What's 1 minus sine squared? Cosine squared, you square root, boom, you got cosine. Okay, so it allows you to use all these identities and get tons of much easier integrals. It opens a lot of doors. So just like U sub, then U sub back at the end for the trig expression, and that also is a little harder than U sub because you'll have to do some thinking there. But that's the basic idea. All right, sub in, integrate, sub back, kind of like U sub, but a little more complicated. All right, so just like in well, I don't know how Ms. Cannon taught it, but how I would teach U sub is I start by telling you, all right, let U be this. I tell you what to U sub. You do the U sub and you work it out and you see how it works. And then gradually you figure out, oh, I know what to make U. Same goes here. I'm going to tell you for a while what to make your substitution. And then tomorrow is another trig sub lesson. We'll go you choosing it tomorrow, right? So say you had this first integral we were talking about. Square root of 1 minus x squared. It would make sense to use sine because 1 minus sine squared is an identity. It would not make sense to use tangent. Sorry, cosine would make sense also, but tangent wouldn't make sense because 1 minus tangent squared isn't an identity, yeah? Likewise, you wouldn't use secant because 1 minus secant squared isn't an identity. It's not really anything. So sine makes sense. We'll talk again more about that tomorrow. If you substitute in, it becomes 1 minus sine squared, obviously. And just like U sub, you have to account for the dx. If x is sine theta, then dx is cosine theta d theta. Okay? Now normally when you use sub, you just are boom home free. But in trig sub, you often have to do some cleanup and trig identities before you integrate. For example, when you substitute in cosine squared, square root it, and combine, I think you'll agree we get to cosine squared. We? Now that's something we can do. How do you integrate that? Oh yeah, I did it for you. Okay. I didn't know if you remember. I think these you probably do remember. I'm not sure. But it's a power reduction identity. I am in the habit of taking the 1/2 out front. It's up to you, but that, yeah? Okay, so now we're ready to finally integrate. Can I get a cord on this? I'm going to listen to that tonight and see if in fact you're coughing all the way over here. So see, I'm just kind of curious now. Okay, so what's the antiderivative? if I leave the half up? Come on, you can't integrate 1?
1/2.
Oh, yeah, it's theta. Theta, yeah. What about the integrating cosine of 2 theta?
Plus sine.
Sine of, yeah, there's a half in there, right? If you were to mentally u sub it, there'd be a 2, u is 2 theta, you pick up a half. I don't need to actually show that, dude. I mean, that's going to make the problem harder if you need to show that. Do you all know where I'm coming from? Okay, okay, cool. All right. Now, just like u sub, after you've integrated u sub back to put it in the original x terms. Now, depending on the problem, sometimes that's harder than others. To find theta, you'll look back at your original substitution and solve for theta. What's theta? Inverse sine of x. Okay. Now, that one's easier. The harder one is 1/2 sine of 2 theta. I think it goes without saying, but I'll make sure. Wouldn't you agree that sine of 2 theta is not just 2x? It's just not that easy, right? Okay. So that's a bit of a stinker. I don't know what sine of 2 theta is. I know what sine of theta is. So what can I do to get around this? Yeah, you need to use the identity to get it back to plain old theta terms, not 2 theta terms, which we don't really know anything about. And then, obviously, we still don't have, the theta's gone. We still have theta, and we need to replace it with x. So let's finish. What is sine of theta? That's easy. X, that was the original substitution. Now, cosine of theta might draw on a skill we did back on the inverse trig. Based on this relationship, I could draw a right triangle. The angle is theta, and because sine is opposite to hypotenuse, it's kind of implied that the opposite side is x in the triangle, and the hypotenuse is 1, which then, by Pythagorean theorem, means the adjacent side has to be 1 minus x squared square root. Now that picture allows me to make my substitution for cosine. Cosine then, by that picture, adjacent to hypotenuse, is root 1 minus x squared over 1. Okay? Let's see. Now, first time I learned this, I was kind of a little, taken aback by how something so clean could have such a terrible antiderivative. And yet, if you were to check this, if you were to take the derivative of this, it does eventually get back to something that it does check. Do you doubt me, or do we need to take the derivative?
Kind of want to see it.
No.
Yes.
10 seconds, go, let's go. What's the derivative of sine squared? Sine. Oh, stop it, you sissies. Plus root 1 minus x squared plus x times 1 over 2 root 1 minus x squared times negative 2x. Okay, so here we go. Let's check this out. I hope this works. Okay, so I think a 2 goes away, and so this is negative x.
1 minus x squared minus plus the 2 minus x squared.
So the common denominator is 1 minus x squared. This is 1 plus 1 minus x squared, right? And this is negative x squared. Okay? So 1/2 2 minus 2x squared over root 1 minus x squared. You see it? That. Wow, it's crazy, but true. Okay? Isn't that something? Yeah. Okay, I'm not in calculus shape yet. Okay, so that's the idea. Are you with me on the first example? Okay, cool. All right, then, because this has a different square in it, mostly, an addition in there, you're going to use a different identity here. If you were to trig sub this, you would try and sub for x in such a way that x squared plus 16 would be an identity after I trig subbed it. Now, again, for reasons we'll talk about tomorrow, you would choose x equals 4 tangent theta. You'll see how that works very nicely in a second. What does dx become?
4 secant squared.
4 secant squared theta, d theta. The x is obvious. And you can see then the root, which is really the focus. You get 16 tangent squared theta plus 16, which is going to be beautiful in just a minute. In terms of all the numerical coefficients, how do they all pan out? All the various 4s, and what do I get at the end? 1/4, yeah. 2 of the 4s go away, and I'm left with the 4 from, I guess, from the root, if you like. So do we all agree that? Okay. I'll leave the secant squared for a while, and the tangent, and let's talk that root expression. Now let's do this in one step. What does that simplify?
Secant squared.
Yeah. I pulled, this is how much I trust your intelligence here. We're factoring out a 16 and square rooting it. That's the 4 out front, right? We're left with tangent squared plus 1, which is equivalent to secant squared, but then we're square rooting it. And that's where Ellen got that secant, right? If that's too fast for you, if that's too much, feel free to do it slower. But I am fine if you save yourself that time. I'm going to divide out a secant. And now, this is the other thing about trig stuff, and why you don't learn it as a Calc 1 student. There's still a little work to be done here. It's not ready to integrate. Get creative. What can I do to make this clean?
Break up tangent and cancel things out.
Tangent, like sine and cosine? Okay, so let's go sines and cosines. I agree. Tangent is either sine over cosine in the denominator, or I suppose you could also say cosine in the numerator over sine, either way. Let's bring the secant down. If I bring that secant down, won't it be cosine in the denominator? Right? The secant is here, the tangent is there. And so with that then, the cosines go away, and I just have 1 over sine, which is cosecant. You follow? Okay, when I was preparing this lesson yesterday, I couldn't remember the antiderivative of that. I am embarrassed to say. So I figured you might be the same, so I put them over here. It is natural log of cosecant theta minus cotangent, that's a c, theta plus c, and then we sub that. Let's go with cosecant. I need to figure out what is cosecant equal to in x terms. How do I do it? Yeah, you have to draw a triangle. You might start by dividing the 4 over so the trig expression is isolated. Tangent of theta is x over 4. Based on that, theta is the angle, and what sides are expressed within. Opposite is x, adjacent is 4. We'll also need the hypotenuse, I imagine, along the way. What is it?
16 plus x squared.
Root of x squared plus 16 or vice versa. Okay. So then, what's cosecant of theta? Sine is opposite to hypotenuse, so what's hypotenuse to opposite?
Square root of 16 plus x squared.
Square root of 16, x squared plus 16 over x, I agree. Minus cotangent of theta. I guess I could actually look here. You can look at the picture, but you could also look here. What's cotangent? Yeah, it's 4 over x. So tangent's x over 4, the cotangent's 4 over x, right? Okay. And that's all she wrote. So far, so good? Okay. Let's try one more, and then you'll try 3 on your own. Howdy.
Hi.
How are you today?
Good. How are you?
Super. Thank you. Hey, how you doing?
That's okay. Okay, we're on.
Okay, so here we go. What makes this, you'll see why this substitution works in a second, but again, it's all about this. 9 secant squared minus 9 would amount to secant squared minus 1, and that is equivalent to, secant squared minus 1 is equivalent to tangent. Yes, okay. So you'll see why that works in a second. But you'll see tomorrow that there are three types: a squared minus x squared, or x squared minus a squared, or a squared plus x squared. Those are really the three types of trig cell problems we're going to deal with. And we really only use sine, tangent, and secant. Yeah, because those are the positives. We could use cosine on the three c's, but they're negative, so we typically don't. We usually use sine, secant. That's one. So let's sub. Dx becomes 3 secant theta, tangent theta, d theta. X is obviously 3 secant theta. We just talked about this, but we'll show it in 2 steps. 9 secant squared theta minus 9. Altogether, the numerical part would be 2 of the 3's divide away, but I'd still have an extra 3 in the denominator. The secants certainly divide away. What happens when you take out the 9, use an identity in square root? It comes into tangent squared, square rooted, so tangent, yeah? And that doesn't even get any easier than that. That means you're just integrating d theta. Well, if you can't integrate that, then get out. What's the antiderivative? Theta plus c. And this is actually not too bad either. I don't even have to draw the triangle, really. I could just kind of look at x over 3 equals secant theta and say that theta must be inverse secant of x over 3. Okay? Cool. What if they had a cosine expression here? What would be here? That could be two. Okay. That's the big idea. Are you with me so far? Try it on your own. Actually, the third one got to be a little redundant, I thought. So A and B should be sufficient practice. Okay.
Yeah, that still does not look
Feels like I'm trying to make your life harder, but this is actually what it'll kind of look like tomorrow when you do these. So I was kind of trying to get you. If this is easier for you, that's fine. Okay? Maybe that's easier. Tomorrow when you make your substitutions, this is actually what it'll start to look like, this right there, but we'll get to that. Okay. Sorry, I didn't mean it. I was trying to help.
4 over 5.
we have to make it up tomorrow. But today,
What do you mean?
no. Tomorrow we just cosine squared of
What is that? X squared plus a squared minus
Don't worry about that. It's not hard right now. It's going to be important tomorrow. It determines what we use for
Oh, like what's under here?
what.
Oh, okay. That's not that bad then. Hey, where are you? Rob, you need assistance. Nate, we have been using
Oh, yeah,
I was insane for a second. I was like, why did I put? Oh no, I did put sine. That. Use yourself. Yeah.
D theta, not right. But you put D theta, you just were like, yes. Yeah, so 60.
Oh, wait. You have it right. Oh,
Okay.
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 What's going on? What's mine?
I'm going to be showing a lot of work here on this, so I have to show this brief stuff.
Oh.
First one.
You have to do it. This is like what's
Whoa, 65.
okay, well,
I feel like all the incidents Wait, Mr.
Yes.
Why is it S16 on the other side?
So on the D, okay, cool, okay. So X equals
Yeah.
So that first one is what you'll probably see is a medium level difficulty. It's about in the 10 to 20 steps. You'll get sometimes beyond 30s.
what?
Yeah, you'll build up to it.
Wait, no.
What side of 1/2?
Oh, I'm so down.
Okay, now remember what that 1/2 is. Is it an X value or a theta value?
Oh, right, it's an X.
Yeah, that's an X value.
So I was going to say it's part of that, so that's going to be. Yeah, that goes in line.
Yeah, me too.
Oh, this is good.
Answer the first one. Takes you 3 minutes just to check your answer. That's a lot of pieces to look at.
Okay. Can you just real quick explain the triangle?
So, your goal is, the big overarching goal is to sub back to get at X terms. We know sine because that was the original substitution, but
Yeah.
cosine, to sub for cosine, you fight the temptation to say, well, theta is the inverse sine of root 5 of x over 4, and then take the cosine. Okay, so some people who are total knuckleheads, and I would hate, would say that cosine of theta is equal to the cosine of the inverse sine of root 5 x. That's garbage. Instead, you look at the triangle relationship implied within this statement. every trig expression is a right triangle trig expression. Theta is certainly the angle, and this is the opposite side and the hypotenuse side. By drawing this triangle, I will have adjacent and hypotenuse sides to look at, which would allow me to subpose them. So I put in the opposite side and the hypotenuse, and find this side by hypotenuse.
Oh, okay.
And then, okay, the last one. Whoa, baby. It's good. Counts are good because then you don't have to do all that triangle stuff. Yes. That's the easiest part. Okay. So while you're starting number 2, the first issue that is always the question is 1/2. What side of 1/2? Now remember, that's not a theta value there. That's x is the variable of integration, so that's an x value. And that means x is 1/2. What's theta? Theta is 5%. All right. So make sure you do your inverse trig, not your trig. Then everything else is cool. 1 sin squared. The x's. Does this clean up a lot or just a little? Sine squared. Oh, that's nice. So that cleans up pretty well, actually.
Oh, wait, did you see? Sine squared and squared equals squared.
They're known to the offenders, you can be explosive.
Still checking about that.
Yes.
Between 1 minus cosine theta. And then do 1/2 minus 1/2 cosine.
Say that again.
Sine squared theta equals 1/2 minus 1/2 cosine.
You don't have to take the half off one.
Yeah, you're less of
How's that going?
Why is it?
The first one is E, so I see the conversion.
Okay. Are we good? Okay, let's move on to the homework questions then. Okay. If this is like the last class, we'll get through about 2/3 of it, so you'll just turn it in and we'll finish going over it tomorrow. But I want to check that you at least did it. Okay, so for number 1, upon checking, it's infinity to the 0, which is indeterminate. Doing all the L'Hopital work and exponential work, you result in 1. I'll go back over questions later. I'll talk a little bit as we go, but mostly I'll be checking your answers. Okay? Oops. I forgot the 7. What are the 7 indeterminate forms?
0, 0,
0 times infinity, true. What else? Infinity minus infinity. Okay, yes. 0 to the 0. 1 to the infinity and infinity to the 0. Okay. All right. Going back to this then. I didn't intend. I intended that you would see this in 2 pieces, not 3. I had people looking at this as 1, 2, 3 pieces, and they got infinity over infinity to the infinity, which is not only indeterminate, but super indeterminate. Okay? That's not a real thing, by the way. Don't ever say that in college. They'll think you're an idiot. Okay? There's no such thing as super indeterminate. But it is indeterminate, either by virtue of, I don't know what that is, so I can't take it to any exponent, or whether you just look at this is what I intended, that you would just use end behavior and look at that one big thing as approaching 1 to the approaching infinity. Either way, it's indeterminate. And after you do all the work, I got 1 over e. Yes? Okay, the last one is 0 to the infinity. Is that an indeterminate form? No, if you take a small thing times itself many times, that's going to get really small. So this is 0. Okay? The rows here is a pedal at 0 because cosine maxes out right away at 0. 1 at pi over 3 and 1 at 2 pi over 3. 1 at 2 pi over 3 and 1 at 4 pi. That's what I mean. Okay? 5 sine 2 theta, your first pedal is... So, what did you do with the scale? Because 5 doesn't fit on the graph. Did you say, forget it, I'm going to go out off the graph? You just said, here's 5. Really? Did you do that? Whatever. Okay. I didn't. All right. Whatever. That's one way to do it. You just call every magnitude that right there, and everyone looks exactly the same. That's great. So I assume then your next one was here.
No, I made the first line 5 and then this next.
So you went 2 years?
Yeah.
I don't understand. Whatever. Okay. There should be 1 at 0, 1 at pi over 4, 1 at pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4. They should be evenly spaced. Okay. 3 sine 5 theta. We talked about that yesterday.
Yeah.
Okay. 1 at 18 and so on. Okay. Did we talk a little bit about the areas and using symmetry and how to do this? Okay, so just checking your answers then. 4b was 12.566 or 4 pi, I imagine. 5b, I had 39.2699. Are we successful so far? Okay, C, or 6, whatever, it's 6b rather. 157.0796, and 7b was 7.0685. Okay, good, excellent. I like it. Okay. Okay. So, arc length is actually one of the biggest reasons you learn trig stuff. You can almost never evaluate an arc length problem without a calculator unless you know trig stuff. So we'll do that. So 7.6403 and 24.3842. We win?
Yeah.
Okay. For this one, A, I got 1 and 3.7621. And for this one, 6.765, negative 1.798. Although you could also have negative 6.765 and positive 1.798. The last class wanted to go over that. It was not good. Do you want to go over that? Okay, just hit that real quick now. Or no? Yeah, move on. Okay, let's just see. Well, maybe we can go back to it. All right. This 4 cosine theta is normally a whole circle, but because of the restriction, you only get a half circle, like that. Symmetric at the x-axis, diameter 4, not radius 4. Same deal here. This is a circle symmetric at the negative y-axis, depending on how you did it. It would normally want to be this circle down here, but the domain restriction makes it only part. Which part, the left or the right?
Left.
It's the right. Okay, why? Yeah, let's look at the first point. At pi over 2, what's r? Negative 5. Okay, so the first point generated would be here. As we go into this quadrant, which we must, let's say we did 3 pi over 4. What sign?
It's negative.
It's root 2 over 2, but then negative, causing it to back up. Yeah. So it's backing up into this quadrant. Okay? This should be a spiral, but because it's a spiral that spirals out is theta divided by something. A spiral that spirals in is something divided by theta. So it's actually spiraling in from 4 to 2, no, to 1. Oh, never mind, sorry. To, what the heck? Oh, I changed my scale, sorry. My scale is, what's my scale? Oh, yeah, that's right. Okay, that's a half. Okay, so this, when I put in pi over 2, I get 2. When I put in pi, I get 1. 3 pi over 2 is 2/3. 2 pi is 1/2. 2/5. So on. So it should be looking like this. Where does it end? It ends here, and what is r at that point? A quarter, yeah, it should be a quarter. Okay, it should look something like that. What's that equal 5 pi over 3? It is a line. I'm so pleased you didn't say a straight line, which absolutely makes math teachers crazy. What other kind of line is there? That's the dumbest thing I've ever heard. Okay. No, linear or straight, period. That's it. Okay. All right. What are the 4 facts about polar rectangular? Give me one. X squared plus y squared equals r squared. You can square root that, and that's fine too. What about x? What's x equal to? Y? And what's a y-x theta relationship? Y over x is tangent of theta, or some form of that, tangent inverse. Okay? What's the easiest way to get this rectangular? What's a good first algebraic step before you substitute? That's terrible. Give me something better.
Multiply it by sine of theta cosine.
No, don't multiply that. What did you say?
Multiply by sine of theta cosine.
Okay, you can multiply. Okay, there you go. Oh, is that what you said? No. Sorry. Multiply. I apologize. No, you're wrong. Sorry. It helps to multiply that over to get those r's and sines together. Okay. This one feels like it's breaking law of math to students. Okay, you have been taught, and taught well, to never divide out a variable. But this is an exception to the rule. You don't divide out variables because you lose 0 as a solution. But in this case, if you divide out r, you still have on the graph 0 as a point. And so it's not lost, and it's okay to divide out an r, which makes it easier to solve for r. Certainly, r is, yeah, the ugly form is this, but the common form of the parabola is tangent secant. This depends on where you put your origin as a point of reference. Where did you put your origin? Middle. All right. If you put it in the middle, no, I'm with you because I didn't even know. That's what my answer is based on.
Let's just assume that.
Assume what at the bottom?
So you didn't say
I didn't say assume the origin's the bottom.
It's always there.
Sometimes you can get it on a Ferris wheel not at the bottom. Sometimes it's kind of here. And you, whatever. Okay. So at any rate, if your origin is there, your equation is negative 30 sine 8 pi t over 5. And your y is negative 30 cosine 8 pi t over 5, 4, 0 to 5. That's if you put it in the middle. You still, wouldn't you agree that this point, I assumed a scale of 1 meter, so this point to me would be 0, negative 30. Because it's a 30 meter radius. So I figure like you've got to have 30 in there.
Wait, I didn't put a diagram on my X. On my
Okay, oh actually that's a good point. Now you might not have had a negative. Now that goes to which direction you said it moved. I said it moved this way. So in my mind X went negative first. But if you said it was decimal, it would be okay, I didn't specify. On a test I would be very clear, hey, put the origin here, this direction, so they all look the same. Okay, this, try what? Okay, real quick. So you said you put the origin here, which is 0, 0. Which direction did you go? Clockwise or counterclockwise?
Counterclockwise.
No.
Clockwise?
Clockwise.
That's clockwise. Okay. Yes, they're asking me to check their answer this way. You're right. It could be either way. What's this point then would be negative 30, negative 30, 30, 0, 60, 30, 30. So x would be, what was the time frame of each point? 5/16? Is that correct? 5/16. X would go from 0 to negative 30. In that case, x is going to be negative 30 sine 8 pi over t over 5. X is that, yeah? Y, however, will be different. Y will be 0, 30, 60. So y would be 30 minus 30 cosine 8 pi t over 5. Okay. Boom. This, I had a lot of people say, it's so fair, you never taught me that before, boo-hoo. Come on, my dog could do this problem. Serious. I told you what to do! Jeez Louise. No, my dog's an idiot. Okay. Sorry, Duchess, I feel bad now. All right. So, your goal is to take this rectangular equation and parameterize it. Parameterize it, which is to say, introduce the parameter. X equals what? The easiest way is just to say x equals t, which I believe I told you to do. And y then, if x equals t, then y must be t squared. Boom. Parameterized. Done. I told you. Okay, wouldn't you agree that if you eliminated the parameter back, you'd be right back to y equals x squared? Yeah. Okay. Okay. Now then, This actually, by the way, this would be all time. You would not say time positive because then you'd only get the right side of the parabola. It wouldn't match the original problem. Okay? All right. Now, what if, actually, let's go back here. If I looked at this, as time goes on, when I say time goes on, time increases. Just time always increases, okay? As time increases, what does x do? Increases. So what direction is the movement? If x is increasing, I'm moving to the right, okay? The direction of movement is that way. What if instead I wanted you to parameterize that equation but have it move left?
Set x to -t.
This is supposed to be 19, sorry.
X equals -t.
Oh, come on. What does 11 have to do with anything? We're supposed to just...
X equals
Oh,
-t.
you know, you made a mistake. Screw it. I give up. I don't have to do it.
X equals
Yes, you are. Okay. So it's supposed to be 19. How do I get it to move left?
X equals -t.
Yes, x equals -t. That's how I feel. X equals... Hello? What about this, though? How do I get the...
T squared.
It can be t squared still because the square would still take out the negative. Okay? All right. How could you parameterize it so it moved 2 units every 2 units per second in x horizontally? Put this in a calculus. What does that imply? Okay, so I like to think of as dx dt as 2, which implies x is 2t. I suppose you could have a constant. So y equals, yeah, now you want it to come out to be x squared. So if y equals x squared, then y must be 4t squared. If x is changing at 2 units per second, then in calculus terms, that means the rate of change in x is 2. Turn this in today, I'll get it back to you and I'll finish tomorrow. Are you understanding this?
Yeah, I think that's
Okay, so to get the equation for x, I have to integrate. So I integrated both sides basically. I separated. So I think there's 2t. I didn't really sweat a plus c in there. With me?
Yeah.
I'm going to come in to you for vector calculus.
Okay, I'll be here.
I went it to me last semester, but then you're gone.
I hear you. I'll be here. Are you with me?
Yeah.
Okay, so now I'm trying to get the y equation. So I know y equals x squared. X is 2t. Where's it all?
Oh, that's it.
No, I was thinking a series of
You're up. You're welcome. Have a great day.
Thanks, Sebastian.